Hey everybody, welcome to 10.1, Distance and Midpoint Formula. So I want to tell you that the distance and midpoint formulas are actually very easy formulas. The confusing part about today's lesson is how we're going to use a lot of different math from your past and from GO2 that you probably don't remember, and we're going to apply these formulas to those other situations. So that you might find today's lesson hard just because a lot of this is going to be review from the past, which you might not remember. Just to start off with, let's define a few terms. A perpendicular bisector. Perpendicular bisector. Okay, so what's happening with that is two lines form a right angle. Two lines form a right angle. And one of the two lines cuts the other in half. So two lines form a right angle and one cuts the other in half. An equilateral triangle, in case you don't remember, all three sides the same for an equilateral triangle. A scalene triangle is a triangle where all sides are different. And an isosceles triangle has two sides that are the same. That's supposed to be a triangle. So scalene, all sides different. Isosceles, two sides are the same. And equilateral, all three sides are the same. And then here's our two formulas, which is the main part of the show for today. The distance formula is d equals the square root of x1 minus x2 squared plus, actually, you know what, I did that wrong. Sorry, x2 minus x1 squared plus y2 minus y1 squared. And just a reminder about formulas that have used these x1, x2 in the past. Remember, x1 and x2, it doesn't mean x times 1 or the first x or, I don't know, anything like that. It's just a labeling system. So I can use x1, y1 to represent the fact that one of these is one point and the other one is a different point. That's why I use those. And then here's the midpoint formula. The midpoint formula actually creates an ordered pair, so you're going to get an x comma y, and for the x value, and actually what you're doing is finding the average of the coordinates. So to find the x value of the midpoint, x plus x divided by 2. To find the y value of the midpoint, y plus y divided by 2. So now the only tricky part about this is watching your negatives. That's where I see students mess up sometimes, is if they drop a negative. So let's go through here. I'm going to find the distance and midpoint. Let's say that negative 2, 5 is x1, y1, and 3, negative 1 is x2, y2. So then let's go ahead and plug this into the formula. So x2 is 3, x1 is 2, and this is where I'm saying careful with your negatives, because there's a subtract and then there's a negative also. Okay, and then y2 is negative 1, subtract 5. What I personally like to do is find these. So this is really negative 3 plus 2, so that's 5. And then this ends up being negative 6. And notice that if you're just going to type this into your calculator, you must use the parentheses. Because remember, negative 6 squared is a different answer than negative 6 squared in parentheses. And we want the one with the parentheses. So right now, really, it's like 25 plus 36. When I take the square root of that, it's approximately 7.81 units for the distance. And then the midpoint, again, let's go ahead and plug into our formula. So this time I'm taking x1 plus x2, y1 plus y2, and it's really finding the average of the points. So negative 2 plus 3 is 1, 5 plus negative 1 is 4, and 4 over 2 is 2. So 1/2, comma 2. Why don't you pause the video and try B really quick? And I'm moving through these first ones because the rest of the lesson is where it gets more difficult. So go ahead and pause and try B. When you unpause, I'll have the answer showing. All right, and then one quick comment. If you're someone who just always types everything into your calculator, don't forget, if you're going to do that, you have to put parentheses around something if there's more than one thing going on top of a fraction. Alright, so now we get to go to the applying these two formulas. So the rest of the examples today are going to be how to use the distance and midpoint formulas in different ways. Please do not skip any examples. You can fast forward if you're understanding, but don't skip any examples. Watch all the way till the end because there's lots of different stuff going on today. The first thing is classifying a triangle. So basically, I have 3 points that make up a triangle, so I could graph it to make a little picture if I wanted to. I don't have to though. The question is, what type of triangle is this? And remember, we know what type of triangle based on what's happening with the side lengths. So in a sneaky way, they're asking us find the distance of all the 3 sides, and then I'm going to compare the distances to figure out what type of triangle it is. Now, sometimes, I guess I'd said you don't have to draw a picture, but I'll just throw it out there. For some of you, it might help to draw a picture. 2, 3, 4, 5, 6, and then 6, 1, and maybe label it A, B, and C or something, just so you know which side you're finding, so you don't get them mixed up and find one more than once or something like that. Your choice though, if you don't have to do that. I'm going to find this side here first from 4, 6 to 6, 1. So here I go. So I'm going to do x subtract x squared plus y subtract y squared. I end up with 2 squared, which is 4, and 6 minus 1 is 5 squared, which is 25. So I got the square root of 29. And honestly, it's to your advantage just to leave it like that for these ones because it's more easy for me to compare them later, and why spend extra time typing into your calculator when you don't have to. Alright, next I'm going to go from 6, 1 to 1, 3. And so I am going to do 6 subtract 1 squared plus 1 subtract 3 squared, and 6 subtract 1 is 5, 5 squared is 25, 1 subtract 3 is -2, -2 squared is 4. Oh, sweet, square root of 29 again. Last but not least, I need to find this side between A and C as how I labeled them, but anyways, I've got 1 and 4 for my x values, so 1 subtract 4, and then I've got 3 and 6 for my y values. Alright, 1 subtract 4 is 3, squared is 9, 3 subtract 6, 3 squared is 9, so that's the square root of 18. Alright, so I gave you those definitions earlier, so now I can classify right now I've got 2 sides the same. Based off of what we said earlier, if there's 2 sides the same distance, it's an isosceles triangle. I'm only going to do one of that type of example because it's kind of long, and so if you really need to go back and watch it again, you can, but that's all I'm going to do for that type of problem. So that's classifying a triangle. The next thing that we're going to do is create an equation of a line, and we're actually going to create a perpendicular bisector line, but before I even do that, I need to remind you how to create an equation of a line. So, quick review. We have a slope formula, which is y2 minus y1 over x2 minus x2, or x2 minus x1 I mean. And by the way, this was done in chapter 2 of Geometry 2. So it's probably been a while since you've seen this. Remember, slope-intercept form of a line is y equals mx plus b. And then there's another point-slope form of a line we could also potentially use. So if I'm going to make an equation of a line, when they just say make an equation, they mean they want this to be our final answer. And this equation of a line contains the slope, and it contains a y-intercept. So those are the 2 things that I am going to need to find. When I make an equation of a line, I'm going to first find the slope, and that's the first step no matter what other method you use. After I find the slope, there's 2 different methods I could potentially use to solve. But first I'm going to find my slope. So again, y subtract y on top, x subtract x on bottom. So I get 1 over -3. Alright, so -1/3. And then now there's 2 different methods you could use to find your equation. I personally like taking these 2 points and plugging it into the point slope form and then rearranging it. On the other hand, or actually I take it back, I guess I'm just going to use one of the points. On the other hand, some people like to use y equals mx plus b and solve for the y-intercept and then plug it back in. So either one is fine. Here's what I'm going to do. I'm going to take point slope form. I'm actually not going to use both points. I'm just going to use one of the points, and I'm going to plug it in for x1, y1, and m. Y and x I'm just going to keep as y and x. So the y value of the point I picked is 3. And by the way, if I pick the other point, I should get the same answer. Slope is negative a third. And then the x value of the point I picked is 2. And now if you use this method, all I have to do to finish this problem is to rearrange this. So I'm going to distribute the negative a third. Negative a third times negative 2 is positive 2/3. And then add 3 to both sides. So there's my equation of my line. And use your calculator or by hand, but I end up getting 11/3 when I add that together. I do want you to change it back to fraction form today. So if you do use your calculator, just use that math fraction button to get back to a fraction form. All right, so the entire reason why we did that was we're going to find a perpendicular bisector equation of a line. And now remember, perpendicular lines have opposite reciprocal slopes, if you remember. Okay, so here's what we're going to do. To find a perpendicular bisector, first, we're actually going to find the midpoint of the segment. Because what's going to happen is I'm going to have a line. I'm going to want to draw a perpendicular bisector right through that line. So in order to figure out what this is, I need to find where the middle of the line is, and then the line I create is going to be perpendicular. So my steps are, I'm going to find the midpoint of this segment. Whoa, I don't know if you just heard that, but I think the Vikings just scored again. It's my husband screaming in the background. Okay, so I'm going to find the midpoint of the segment that's given. So that right there is in black representing a segment that they gave us. They'll always give you that. So I'm going to find the middle of that. And then I'm going to find our slope. And let me say this, if I find the slope of the segment given, so find the slope of the segment given, then our slope is perpendicular, so our slope is going to be opposite reciprocal of that slope. And last but not least, so in order to create the equation of a line, as you saw up here, I need to know the slope and a point. So this gives me the slope and a point. So then just plug it in to that to rearrange it. So actually, really, steps 1 and 2 are the confusing part. Once you have that written down, flip over and let's do this. Okay, so I personally like to kind of draw a picture just so you can see what's happening. So I want to write an equation for the perpendicular bisector of this segment. So what's happening is I have this segment, 2, 3, 4, negative 1, 4, 2, 1, 2, 3, 4, 5, 5, comma 2. So that's my segment. I want to find a perpendicular bisector line of that segment. So basically, I want to create an equation for that blue line I just drew. And in order to create an equation of a line, I need a point and I need a slope. The point that I'm going to have here is the middle of this segment. So first, I'm going to find the midpoint of the segment given. And that's the same step 1 I did on the other side. Okay, so my midpoint, add my x's, divide by 2, add my y's, divide by 2, and you end up with 2, 3. 6 divided by 2 is 3, 4 divided by 2 is 2. Okay, so I found a point. Next, the slope of this blue line that I'm trying to create it's perpendicular to the segment. So if I can find the slope of this segment, the opposite reciprocal of that is what my blue line slope is. So the slope of the segment is going to be y subtract y over x subtract x, 2 over negative 6, so negative 1/3. Okay, so if that is the slope of the black line. So our slope of the blue line is the opposite reciprocal. Opposite would make it positive. Reciprocal would make it 3 over 1. So our slope is 3. Then, step 3, I'm going to use that and that in my formula and rearrange. So I'm going to plug in y minus my y, which is 3, equal to my slope, which is also 3, times x minus my x, which is 2. And then I'm rearranging it. Distribute the 3, and I've got y minus 3 equals 3x minus 6. Okay, final answer, y equals 3x minus 3. That might have been kind of difficult for some people, so if you'd like to pause and try on your own, please do so. But when you unpause, I'm actually going to talk through the whole thing, so feel free to fast forward it. If you've paused it, tried it on your own, you got the correct answer, forward through my explanation and go on to example 4. All right, so once again, I'm going to draw a picture just so I can see what's going on here. So I've got a segment joining 2, 2, and 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, way up there. So I want to create an equation of this blue line. So first of all, find the midpoint of that segment. So the midpoint of the segment is x plus x over 2, y plus y over 2. So that is my midpoint, 4, 8. Find the slope of the black segment, and then my slope is opposite reciprocal, okay, because it's perpendicular. Okay, so slope is y subtract y over x subtract x, which is 3. So our slope this time is -1/3. And you might want to have a separate sheet of paper or something where you have all these formulas written down. If you're like, whoa, where's she getting this? These are just the formulas I was given. So, all right, anyways, let's plug it in then. So plug in my y, plug in my slope, plug in my x, and now I'm going to rearrange it. And I am going to get fractions this time. So if you're getting decimals, remember, just use your math fraction button, fraction enter, in order to figure out what the fraction is if you're getting decimals, if you don't know it in your head. Okay, so you should be getting -1/3 x plus 28/3 for your final answer. The last application for distance and midpoint formulas are being given a coordinate value, and we're trying to figure out what one of the other coordinates is. So here I am using my distance formula again. All right, there's my distance formula, only this time I'm plugging in d instead of having d be the variable. So if I look at this then, my x values are 0 and x, and my y values are 1 and 4. All right, so here's what's happening then. I need to solve this. Now don't overthink this, okay? First of all, let's just simplify a little bit. So 0 minus x is -x. 1 minus 4 is -3. And now to get rid of the square root, I'm going to square both sides. And remember, a square and a square root cancel each other, so this just ends up being 34. And on this side, I now have -x squared plus 3 squared is 9. And now just a second, see how -3 squared is 9? This is really -x times -x would turn into a positive x. So at this point, I can just write x squared. Once you get there, it's easy. Just to that step is where it's kind of tricky. So here I'm going to subtract 9 from both sides. And x is going to be 5 or -5. Remember, it has two possible answers when you square root something. Okay, why don't you go ahead and try B, and I'll just give you a hint. Your answer is going to be a decimal. So if you're going through this one, you're going to end up with a decimal. Why don't you pause and get as far as you can, write in pencil, so that we can erase if you make a mistake, and then we'll see what you're getting here. All right, here is my final answer. And I want to tell you the one thing that's tricky about this one is I can't find y minus 2 squared. Remember, if I really wanted to, I would have to write it out twice and FOIL it. I hope nobody tried to distribute the exponent. Can't distribute if there's a plus or minus sign. But it's way easier if I just leave it like this, because after I square, this square cancels out the square root, and 8.5 squared is 72.25. But anyways, I can subtract over and square root later to get rid of that square, so it's really to my advantage just to leave it. And then remember, when you square root, you get 2 answers, so I got to try to find both answers. And you know what? I just did something wrong. I knew that seemed a little funky. Okay, I was supposed to do plus 2 plus 2, so the other answer is actually y equals negative 3.477. Good, that sounds better. All right, thanks for listening. Make sure you write down your questions, and we'll talk to you again soon.